Improving students' learning with effective learning techniques, promising directions from cognitive and educational psychology. Psychologists have been studying the effectiveness of learning techniques for over 100 years. Still, some effective learning techniques are not used and some ineffective learning techniques are overused. For the purposes of this study, 10 learning techniques were chosen. To select the specific learning techniques, the researchers used a survey of literature techniques and techniques that students described using frequently. Then they limited the techniques to 10 by choosing those that could be independently used by students with very little training. Also, the final learning techniques had to have adequate research to justify their effectiveness. The 10 learning techniques chosen were then evaluated for generalizability by choosing 4 categories of variables. The first variable, materials, refers to the content students are expected to learn. The next variable, learning conditions, refers to the environment that the learning takes place in or how the learning techniques are applied. The third variable, student characteristics, refers to several aspects. It could be age, cognitive ability, or background knowledge. The final variable is criterion task. This refers to the objective of the criterion the learning techniques is to be used for. For example, some of the learning techniques explored deal with memory and some with comprehension and the ability to apply the knowledge that is being learned. The goal of this study was to ensure that students were able to match the appropriate learning techniques to the goal of instruction. Elaborative interrogation is the prompting of students to find the answers to questions by asking why. The technique is effective because it has been shown to expedite learning, and it also coincides with the innate trait of humans to understand the world around them. In a study performed by Presley, McDaniel, Turner, Wood, and Ahmad in 1989, students were given statements about a man. 3 groups were formed and asked different types of questions. In Group 1, or the elaborative interrogation group, the students were asked why the man performed a certain action. For example, why did the hungry man get in the car? Group 2 was given an explanation of why the man performed the action. For example, the hungry man got in the car to go to a restaurant to eat. The third group just read the statement. The hungry man got in the car. On a final test, the elaborative interrogation group outscored both of the other groups, performing with a 72% accuracy. The other 2 groups scored about 37% each. Other formats of questioning have been used in studies of elaborative interrogation, such as, why does that make sense? Why is this true? And the most prevalent, why is one fact true and not the other? Elaborative interrogation supports the assimilation of new knowledge and previous knowledge to heighten learning. According to Willoughby and Wood in 1994, during elaborative integration, learners activate schemata. These schemata, in turn, help organize new information which facilitates the retrieval. Hunt went further to say that organization is not all that students need. They should also be able to discriminate between facts that are similar to accurately identify or use new information. In Presley et al., elaborative interrogation was shown to have an effect in both incidental and intentional instruction. In most studies done, elaborative interrogation was observed through individual learning, but research conducted by Call and Woloshin and Stockley noted effects of elaborative learning in small groups. Elaborative interrogation is shown to improve learning in high school students, middle school students, and upper elementary students. In a study done by Green, Simons, and Richards in 1996, and another study done by Scruggs, Mastropieri, and Sullivan in 1994, effects of elaborative interrogation in students with disabilities in grades 4 through 12 was also noted. According to Wood and Hewitt in 1993 and Wood, Willoughby et al. In 1993, effects were also shown with high-achieving students in 5th and 6th grades. Woloshin, Presley, and Schneider performed a study in 1992 with Canadian and German students. Each group was presented with facts about both countries. Students, of course, had more background knowledge of their own country, so effect sizes of elaborative interrogation were higher when they were asked questions about their own country, and significantly lower when they were asked about the other country. So prior knowledge did play a significant role in their performance with elaborative interrogation. Studies in elaborative interrogation have evolved from the Mann sentences that Presley et al. Used in 1987. The research that has followed has used materials that involve presenting a fact and then following it with an elaborative interrogation. Others have shown effects of elaborative interrogation by using fact lists across a variety of topics. It is vital to point out that elaborative interrogation is almost always used and applied in instruction using facts. One concern noted is that meaningful delays in retention have not been studied when using elaborative interrogation. More research is needed to show if elaborative interrogation's effects can generate long-term improvement. Most of the studies of elaborative interrogation have depended on measures of memory. Some used cued recall and fact recognition as well. Free recall tests have been shown to have mixed results. Only 3 studies have been done to show the effects of elaborative interrogation using comprehension and verification tests that entailed higher level thinking. Most of the research to find the effects of elaborative interrogation have been completed in labs, but in a study performed by B.L. Smith et al. In 2010, undergraduate students in a biology course participated in an experiment during class. In the first week, students took a test on material that was similar but not the same as target material. During the second week, the students were given an assignment to read a chapter in their textbooks regarding human digestion. Half of the students were given elaborative interrogation prompts and half were told to read and study the text independently. Then the students were given a true-false test of 105 questions. Performances by the elaborative interrogation group proved to be much higher than the control group. Elaborative interrogation offers some attractive advantages. Little training is required to gain effect from this technique. It also requires very little time to incorporate into lessons. The greatest challenge to the elaboration interrogation is that it is most effective when used with fact-based instruction. In order to implement this technique with more complex studies, students may struggle with how to choose material to question. The example provided by Dunlosky states, when learning about a complex causal process or system like the digestive system, should the prompts focus more on an entire system or only a small part of it? The authors of this study consider elaborative interrogation to have moderate utility. They concluded that elaboration effects have been shown to be successful when applied with facts, but some concern was raised when effects were studied with material that is more complex. Also, elaboration techniques have been shown to have effect on students ranging from the 4th to 12th grade and students with greater background knowledge. Effects of elaborative interrogation with short delays have been shown, but it is still unclear if effects remain constant after longer delays. The authors concluded that more research is needed in order to generalize the effects of elaborative interrogation. In Berry's seminal research of self-explanation, the effects of logical reasoning were studied with students using the Watson selection card task. In this task, students were given a set of cards and asked to test a rule. At first, the students were given a concrete example to test the rule, which most students completed with a score of 0. After brief instruction, the students were grouped, with the first group being asked to explain while solving the problem and give reasons why they chose certain cards and not others. The next group was just asked to solve the problems and explain how they came to their conclusions. The third group was the control group, and they were never asked to self-explain. The results concluded that all three groups performed at a 90% accuracy, but in another test completed later, which used more abstract problems, the two self-explanation groups achieved greater results than the control group. Dunlosky states the core component of self-explanation involves having students explain some aspect of their processing during learning. Self-explanation may seem similar to elaborative interrogation. They do both draw on prior knowledge to assimilate new information, but they are different techniques for many reasons. In self-explanation, the prompts are much more adaptable across topics of study. Also, in self-explanation, prompts may be either content-free or content-specific. For example, a content-free prompt may ask what a sentence means to you, whereas a content-specific prompt may ask why is the numerator 1 and the denominator 4 in this fraction. Many studies have studied self-explanation in combination with other learning conditions. In 2006, Riddle-Johnson found that self-explanation joined with direct instruction and discovery learning proved to be effective. In 1983, Berry found that students who performed self-explanation after they had solved problems showed improvement. Self-explanation effects have been exhibited in students across age ranges. The bulk of studies have been done with younger students in elementary school, middle school, and high school. Generalizability of self-explanation pertaining to the effects of prior knowledge has not been sufficiently researched. Effects of ability level on self-explanation has been researched, but conflicting evidence was produced. In Chi, DeLu, Chua, and Levanture in 1994, improvements were shown in learning by expository text using self-explanation, but in Didergene and Cosinel-Marmichet in 1997, effects of self-explanation in algebra problem solving were only found in lower skill students. One of the strengths of self-explanation literature is that effects have been shown not only across different materials within a task domain, but also across several different task domains. Self-explanation has been shown to assist in math problem solving, logic problems, helping students overcome misconceptions, number sense, and learning from text. Self-explanation has been shown in research to cover many criterion measures. Effects of self-explanation have been shown in tests of memory, free recall, cued recall, fill-in-the-blank test, associative matching, and multiple choice tests. Research has also concluded that self-explanation affects text learning such as comprehension, drawing inferences, implied information, and far transfer tests. These are tests that include questions that have not been included in regular practice. The effects on the durability of self-explanation are woefully underexplored, according to Dunlosky. In most studies, tests to measure the effects are given within minutes of learning. Only 5 studies were found by the author that introduced longer retention. They range from 1 to 2 days to 2 weeks, but it is evident more research is needed to make assumptions on the durability and lasting effects of self-explanation. Outcomes from 2 studies justify the effects of self-explanation in education. In one study conducted by Schwarm and Wrinkle in 2006, teacher education students were learning how to construct questions. They were shown well-written questions and poorly written questions. The self-explanation group was prompted to reason what made the questions good or bad. The control group was not asked to self-explain. On the final test, the self-explanation group outscored the control group. In the study performed by R.M.F. Wong in 2002, students were given a theorem from their text that had not been studied. Students were encouraged to think aloud during the first session. Then half the students were told to self-explain and the other half were told to think aloud while they read. A study guide was given for the test the next week. Students in the self-explanation group did not improve on information provided or practiced, but they did show improvement on FAR transfer questions. Implementation of self-explanation is proven to be easy to apply across tasks and domains. Students may require little or no training. According to Cosinell and Marmochet in 1997, students with poor skills may need more training to ensure the self-explanations they produce are effective. Time may be an issue with self-evaluation. In the study performed by Chi et al. In 1994, learners were told to self-explain after reading each sentence. This meant more time was spent reading as opposed to the control group, which was told to reread the text. But Schwarm and Wrinkle found no correlation between time on task and performance in their study in 2006. It is clear more research is needed to confirm the merits of implementation of self-explanation. The authors rated self-explanation as having moderate utility. This learning technique's strengths lie in the effectiveness of its ability to be used with many content materials and across domains. It can also be used with a wide variety of ages. More research is needed to determine the role that prior knowledge and ability level plays in the effects of self-explanation. Durability or retention and time for implementation also need to be studied further in order to comprise a complete picture of the effects of self-explanation.